All right, with our active pneumatic downforce, the thing that we are monitoring is margin, and that is the additional amount of downforce applied above and beyond what is required for seed penetration to achieve the proper planting depth. The factors that come into play on margin are the weight of the row unit, the downforce that's being applied to the row unit, and the upforce or the resistance pushing up on the row unit from the soil. Things that downforce impacts. It's going to affect the trench sidewall, ride quality, seed singulation, your seed spacing or your CV value in your display, ground contact, emergence, and most importantly, it's going to affect your yield, 5 to 9%. Impacts to yield because of your downforce. You're going to have a 2 to 4 bushel impact because of correct population, a 2 to 4 bushel per acre effect from uniform spacing. The biggest impact you're going to see is getting uniform emergence at 10 to 18 bushels per acre and achieving the proper planting window at 4 to 10 bushels per acre. And this is based on a study done at the University of Minnesota on a 200 bushel per acre plot. It's important to remember while setting downforce to set enough but not set too much. The amount of downforce needed will vary from field to field depending on your field conditions, varying on your amount of tillage, whether you're no-till, crops you're going through. Running too little downforce is going to cause the row unit to hop and you're going to get poor ride quality. The openers are going to rise up out of the ground, getting poor ground contact. You're going to get improper firming of the seed furrow, improper seed depth, and varying seed depth across the rows in the entire field. Running too much downforce will cause excessive wear on the openers and gauge wheel bearings, shear rivets on the true V hubs, and more importantly can cause compaction of the seed trench sidewalls, resulting in poor root growth. In this scenario, you're going to see what correct downforce settings looks like. On the left-hand picture here, you're going to see, and this is with the closing wheels removed so you can see what it looks like, but you're going to have a defined seed trench. You're not going to have any loose soil with the seed. The seed depth is going to be consistent on all rows on the planter across the entire pass of the field because the openers are not riding up out of the ground. The sidewalls of the trench are not caving in, allowing loose soil in with the seed, causing the inconsistent depth. And the sidewalls aren't going to be compacted, allowing optimal root growth into the soil. And then with the right amount of moisture and sunlight, you should achieve maximum emergence and maximum yields. With too little downforce, you're going to have inconsistent depth. You're going to have trench sidewalls are going to be caving in, loose soil with the seed, and you're going to get inconsistent depth, and you're going to have poor seed to soil contact. The photo on the left, you can see with the sidewalls caving in and you don't see a defined trench. And then on the right-hand picture there, you'll see the effects of too little downforce where you're getting uneven emergence on your plants. Running too much downforce, you're going to see in this, like in this photo, you're going to have the gauge wheels putting too much pressure on the soil, causing that peeling effect, and the trench sidewalls will be very compacted. And because of that, you're going to have poor root growth outside of that trench. The picture on the right is a good one to go off of. After you're going back and checking your root growth of your crop, you have a really defined seed trench still there even after the amount of time that's went by on that, and then it's going to have poor root growth outside of that. I've got a quick video here that gets a little bit more in depth to understanding margin with your active systems.
This video is designed to help you better understand row unit downforce margin. Understanding margin is key to optimizing your planter for both active and non-active downforce systems. Downforce margin is the amount of additional downforce applied to a row unit above and beyond what is required for penetration and to achieve full planting depth. The John Deere SeedStar XP monitoring system measures downforce margin with load sensors located in the row unit gauge wheel depth control handle. Setting downforce margin properly will ensure that the openers achieve full planting depth and that the gauge wheels provide enough firming of the seed furrow to prevent the walls from collapsing. Proper downforce margin also prevents excessive row unit bounce, which may cause uneven seed spacing. To properly set the downforce margin for your conditions, follow these steps. Plant a small test strip. Note the high, low, and average margin value in the lower right-hand corner of the downforce run page. Stop the planter in the lowered position. Exit the cab and check to see what the seed furrow looks like at this setting. Do the walls of the seed furrow look firm but not compacted? Is the seed planted at a consistent depth? Are the gauge wheels firming the furrow correctly? In this example, the correct downforce margin is being shown for the field conditions. Notice how the seed is planted at a consistent depth. The walls of the seed furrow are firm and not crumbling, and the gauge wheels are firming the sides of the furrow correctly. If a field check confirms that downforce is correct for your field conditions, you have determined the proper target margin value for this field. The average and target margin should now be nearly equal. The function of the gauge wheels is to provide depth control and firm the soil against the openers to create a defined seed furrow. There are many signs when downforce margin is not properly set. Too little downforce margin will prevent the opener from planting at a consistent depth because the gauge wheel may intermittently come off the ground. Too little margin may also cause the seed furrow to collapse in front of the seed drop, resulting from too little pressure on the gauge wheels. In this example, too little downforce margin is being shown for the field conditions. Notice how the sides of the seed furrow are crumbling into the seed trench and the gauge wheel tracks are uneven. Low margin may also cause overall row unit ride quality to be poor. The gauge wheels should just barely be able to be turned when in the planting position. If the gauge wheels spin too easily, downforce margin should be increased. If the gauge wheels cannot be turned by hand, this is a sign the downforce margin may be too high for field conditions. If there is too much downforce margin, the side walls of the seed furrow may be compacted. The sides of the seed trench may appear slick or smeared. In this example, too much downforce margin has been set for the field conditions. Notice how the sides of the seed trench are compacted. The gauge wheels also may leave deep tracks or ridges in the soil from too much pressure. If your field check confirms that the downforce margin target is incorrect for your field conditions, you will need to either increase or decrease the row unit downforce setting to compensate and perform the field check again. Watch Using Set Point Control or the Using Active Pneumatic Downforce videos for more information on operating your system.
The three factors at work when a row unit is running across the field are the weight of the row unit, and that's going to include your seed pushing down. This weight's going to go down as the seed hopper is empty, and it should stay consistent with a CCS machine. The amount of downforce that's being applied to the row unit, depending on what system you have or what the operator has it set at, and the resistance of the soil pushing up on the row unit, also depending on the amount of residue, tillage, and ground speed is going to have an effect on that too. So, to calculate margin, you need to add the downforce being applied to the row unit and then subtract the resistance. So we got a quick problem here for you to figure out. On this example, we have 200 pounds of downforce that's being applied to the row unit. The weight of the row unit is 100 pounds, and the upforce pushing up on the row unit is 150 pounds. What would our margin be? $150? Yep. 150 is our margin. The next thing we're going to go through are the different types of downforce that we offer and where we've gone to where we've gotten today. The first we have is the heavy-duty mechanical springs. They have manual adjustment levers at each row and must be manually set. The 4 different settings that they come in are 0 pounds, 125 pounds, 250 pounds, and 400 pounds. And that's a list of the models that the heavy-duty mechanical springs were offered in. Next we move to the most common downforce systems used on the various pneumatic systems, and that's where we have our air springs on each row. They have an infinite amount of settings between 0 and 400 pounds. It's available on all the models, and they come in the standard or integrated with a display. The first of those is the standard pneumatic downforce system that is separate from the planar electrical and hydraulic circuits. This would be your small compressor that you have mounted in the cab of the tractor, and you're going to have a mechanical gauge on that compressor that you're going to monitor, and you're going to have a switch that you flip on and off to pump up the pressure on your downforce and dump valve to relieve pressure on the downforce system. The next we have is the integrated pneumatic downforce system, and this is going to be most likely a compressor that's mounted on the hitch of the planter, and you're going to have a control on the display where you're going to have a pressure sensor that's going to give you a reading in your display what your downforce is at, and you're going to manually have to raise and lower your downforce in the system. When you do this, the controller is going to activate a valve at the compressor to release or add air, and it's just going to monitor your pressure on the display for you. Then we have set point pneumatic downforce systems, and it's going to be the same as the integrated system, but you're going to have a control on the display, and you're going to set a target pressure, and the system is going to maintain that air pressure in it for you to keep at that target that you have set. On some of these systems, they have gauge wheel sensors mounted in the select rows, so then you can monitor the row unit ride quality, the ground contact, and margin, but this is just something that you monitor in the display as you're going. Like I said, you're going to enter your target downforce in the display, and it's still going to be a controller activating the valve to relieve and add air to the system. Then we get our active pneumatic downforce system, or our SeedStar XP, And this is going to also be the same as the integrated system. It's going to have the gauge wheel sensors mounted on the selected rows. It's going to monitor the row unit ride quality, ground contact, and you're going to have margin bar graphs. The biggest difference on this is from the other systems. The other systems, you're going to be monitoring the pneumatic downforce pressure on it. This, you're going to be entering a target margin value, and that's what you're going to be monitoring. Another big difference with the active system is you're going to have the big hydraulic compressor like we have on the back of this planner here, so it can make those quick changes to the system as you're going through. Then we get past that, what we have on this planner here is our individual row unit hydraulic downforce system. It's going to have the downforce reading on the display and everything like our active system, but it's going to have gauge wheel sensors in every row, and it's going to make adjustments to individual rows up to 5 times a second. It's going to monitor your ride quality, ground contact, margin, and the applied force on your bar graph, and it's going to make changes to field condition changes. Also measures in margin like your active pneumatic does. And the controller is going to activate a solenoid at each individual row to control the oil pressure to each actuator and accumulator on this system. With the IRHD system, you're also going to get on-screen diagnostics for diagnosing problems. This system isn't recommended for 6R tractors or IT4 or 7R tractors because of the hydraulic requirements needed to run the system. And then we have this was showing you what your run pages would be for the individual row unit hydraulic downforce system, whether you have on the left with your Seedstar 3 running on a 2630 or Seedstar 4 running on your Gen 4 display. And then finally, the thing I just wanted to hammer in your head, I guess, is if you have the active pneumatic downforce system and you think you're running in it, it's always good to check. If you have the active system, you also can run in set point mode. The biggest thing to keep in mind is if you're running in the set point mode, you're going to have this fork icon, and that's going to be monitoring and maintaining pressure in the system, and it's not going to react to the field changes. If you're running in active mode, you're going to be measuring margin on the system, and it's going to have the pieces of the pie similar to like what you'd have with the auto track pie chart, showing that it's meeting the conditions needed for it to become active. So that being said, we'll go over to Lance and poke some buttons.
All right, so kind of picking up where John left off. First, kind of want to talk about just some of the components here as part of the downforce system. So this 1790 planner has active pneumatic downforce, and it has 3 sensors on the front range and 2 on the back range for a total of 5. Just a regular 16-row planner is going to have 3 sensors, and then a 24-row planner will have 5. Kind of what we're looking for, and you can look at this if you want to see in just a little bit. But on the second row in, there's a row that's got a black node, and that is our ride quality node. And so, those are over here. This is what I'm looking at here on this node here. And then our downforce connector is right below, and that downforce connector goes in here on this depth stop for our gauge wheel. So that's where the components are at on the system. I always kind of like to go over that first, so you know what you're dealing with. So we're going to come back here to the screen, and on our screen, I'm going to touch the bottom left. I'm in our Seedstar XP. So this bottom left button has everything to do with our downforce. And right now, just mention the difference between set point and active. Right now I'm in set point mode because I see the fork right here. We have active pneumatic downforce, and so we're going to enable that by checking this box. And now at that point, I am working in margin. And so this is my margin number. A lot of times people ask, okay, what is a good starting number? I usually like to start around 75 to 100 pounds of margin. Just for display purposes here, we're going to have to be a little bit higher. Like I said, we've got the blocks underneath there to try to simulate what's going on. But I really want to start by focusing in here on this pipe. And so the first one in the top left that says that, hey, we have the sensors, we have active pneumatic checks, we're good to go there. The second one here in the top right third is our speed. So there's a couple different speeds that we need. We need tractor speed, whether we're getting that from a GPS or radar. And then we also need planer wheel motion sensor speed. So you can see now that's turned red. We have a couple simulators here to simulate the speed on both of them. So we can honestly, we can use this as a diagnostic tool. So if we're not meeting one of these conditions, we know, okay, I need to check something out with speed and see kind of what's going on. Then this bottom one here, I can remember that easiest because bottom means I'm putting the planer lower. So when we lower this planer here, when that road unit button is tripped, at that point, fills in that bottom here. That is green, that's green, that means we're engaged. So you can see right here that my current margin for this example is 180, and this is my actual. Running around that 180. You can see over here that we do have speed. Right, this number over here, this is what the planner is actually putting down. So in a sense, if I'd be running in set point mode, that's that number. I'm really not too concerned about that, especially when I'm running in margin. This number here, just we want to make you aware that on our pneumatic downforce systems, they can put down around 400 pounds total. And so a lot of times if we're putting that much downforce down, there's chances are we could have too much downforce, or we're in some really compacted areas or some really tough ground. And that's really where we can start to see, kind of like John talked about, some of those wear on those true Bs as well. So that's, like I said, that's that number. Down here, we're going to get our margin. We're going to get a low and a high as well. And so, kind of moving on, up here, there is my margin bar. And the goal really is to have these kind of right around that middle line or in the black. If they go way up above or way down below, they'll first turn yellow and then they'll turn red. So sometimes we do see that, especially with like a CCS machine. We got seed in it, seed's tank full. That might be a little bit higher, and just due to all that weight there in the center. Another thing that I do want to remind you about, on these active pneumatic downforce systems, they're going on an average. So in this system here, we're only planting corn, we're running on 3 sensors. So it's taking an average of those 3 sensors to come up here with our target margin. So that kind of sometimes can beg the question, what happens if I have a bad sensor? If you have a bad sensor, one will probably throw a code. The other thing is if you have a bad sensor, it's actually going to affect this number here if we're still using that sensor. And so we do have the ability to go disable the sensor, maybe until you can go to your local landmark location and get that replacement part, or if you have a shop come out and replace it for you, we can do that. And that is found in tab G here. Then I'm going to come over to sensor, and then I'm going to come down to downforce. All right, this is also a page that I would like to go to at the first part of the season, even before I go to the field. A couple different reasons. Right now, I can see I'm on sensor 1. I'm going to drop down to sensor 5. So on these split row machines, it goes, the front ranks are 1, 3, and 5. And so over here, I can see that it's not checked. So I'm kind of pretending that either that sensor's bad or I'm not using it. In this case, I'm not using it because if I do check that, there's no load on that. We don't have any blocks underneath it. And so it throws in just a 1. One thing that I do want to advise you of is, and this is kind of where we go at the first part of the season, before we go to the field, but if that is checked, and we still have dashes on sensor 5 for this instance, if that would be checked, I could potentially have an issue with my downforce sensor. It's not registering. And so there is a little connector, probably about that big, that sometimes causes issues. A lot of times I see bad connections, so I'll take that apart, look at those pins, maybe put some dielectric grease in there, and then reconnect it, kind of make sure we have a really good connection there. It can be a little tough to work with sometimes. So that's one thing to check. If that number, there's a number that at least populates, we know, okay, the sensor's back online, it should be good to use it. If not, we may want to look at, maybe it's a connection further on up, or maybe that downforce sensor had its own back at that point. The other thing I want to touch on here, and I'm going to first go back to our main planner page and then the button here. So this is our ride quality. So over here, kind of once again, gives a minimum and a maximum. Right now it says 100%. And so really we want this to be in the black. We want to be, in that high 90 range, mid to high 90 range. And really that's what's going into this equation is, okay, we set our target margin. How good are we achieving that target margin on these rows, as well as what kind of row unit balance are in those rows. So if we're down maybe in the 80 mark, for instance, we're saying right quality 80%, chances are that row unit could be bouncing, but we probably don't have enough downforce. At that point, we're probably not getting our consistent seed depth, which is really going to affect uniform emergence. John talked about that as far as really how uniform emergence affects yield in a big way. And so like I said, I like to see this higher, so we would maybe bump that up. Once again, nothing beats getting out of the cab and checking to see, if our gauge wheels, how they turn. Do they turn freely? Do they turn at all? Are they kind of tough to turn, but you can still turn? That's kind of what we're going for. The other thing I would suggest, as we know that the system does take an average across the whole planner, is when we're getting out to check, just make sure you check several rows, just kind of randomly, make sure, one row when you stop, it may have landed in a really hard spot, so we want to check the other rows. If the other rows are pretty much free-reeling, we know that we probably need a little bit more downforce, as well as, digging in that trench, seeing how side all is, if it's curling in or not. That's one thing we do want to look at. Any questions on that? I'm going to jump back in here to our sensor, and then I'm going to go down to our ride quality, just to kind of talk about our sensors here. Same way with our downforce sensors. That's what that black node I was talking about earlier. I want to make sure I have a number there. If I don't, chances are, 1, I want to check that connection. 2, if it is enabled and there's still not a number there, like I said, check the connection, or maybe we need to replace that node as well. And then a lot of times, being these planner set up, if you have questions as far as what row it's on, it should say here on the screen. And like we know in the 1790s, on a 1631, or odd rows or corner rows. The other one I want to talk about is this PDF air pressure. And so this is kind of the air pressure in the ranks. So this is the first rank here, what I'm going to talk about. And really, I'm going to talk about zeroing that out. And so to do that, we need to relieve the air pressure out of the airbags. I like to do that kind of beginning of the season to make sure, you know, that the sensor says, you know, we don't have 20 or 30 pounds, whatever. Really, this goes in equations as far as actually calculating the downforce putting down, so that can impact the downforce performance. So like I said, the easiest way to zero those is let the air out of the system in the airbags. Whether it's using pulling this line out of this push to connect fitting, that'll really let the air out pretty fast. So that's one way of doing that. Kind of going back here to the main planner page. If I go just to adjust my target margin, I can touch the 180 in this case, use my up or down arrows. If I use my up arrow and hit to the right, we should see, we heard the tank there, and I don't know if an arrow is going to appear or not, but we should see an up arrow if it's filling, or a down arrow if it's going to drain. So that's kind of how we know, okay, we're commanded it to do, it's working. You know, if something's not changing at that point, we might want to go take a look at the valves, see maybe there's, you know, a connection issue there as well. So I'm going to go back just to our downforce here. So I know I showed you that I do not have one of the sensors enabled for this case. It would show up here. So that's why I'm just seeing these two in this case. We're just using those two. One feature on the active pneumatic downforce that we have is this up here, it's our pause feature. And so really what that'll do by hitting that, it's going to pause where we were at for 10 seconds. So say maybe from me to that wall over there, you know, not very far of a distance, maybe we have a little sandy spot, a little bit softer, you know, and we know that, okay, this planner is going to sense that and it's going to drop the air, but after that, it's the same soil that maybe I'm in right now. I can just hit that pause, and so that way it just keeps everything where I'm at, and then when I get back over there, it's not having to drop the air and then right away fill it again. So kind of a nice feature of your active pneumatic downforce system. One thing I do want to hit on as well, kind of goes back to a little bit of physics, but whether it's that planner or this planner, you see we both have row cleaners as well as closing wheels. Right now this one's set on the second notch, but say we were in the first, we go to the second, or we're in the first, we go to the third. What that does, that's more pressure, and so that's pushing down. We know this is a pivot point here, so that's going to lift our main part of that shank kind of out of the ground, which can impact our downforce. So one thing you maybe have to do or watch is, do I need to increase my margin just a little bit to overcome that? Whether that's on the closing wheel side or the row cleaners as well. So something to think about. Make an adjustment to one thing, it can impact the next thing. So like I said, we talked about how good quality downforce is and how it impacts uniform award emergence. So, any questions before I send you on to the next section? If not, we'll be around if you want to ask something as well. So, thanks for coming.
Thank you.